Yeah, thank you. Thank you very much. So it's also really impressive for me because I think I have been here for already more than 20 times as a co-organizer, but that's the first time being here as a speaker. So thanks a lot for having interest in the topic or maybe the presentation. So yeah, today's topic is machine learning with TensorFlow, and it's designed as a getting started session. So yeah, we want to get our hands dirty with training neural networks. But first things first, who am I? My name is Sarah. I studied business administration with a lot of statistics at the University of Passau. Since 2015, I'm working for OneLogic as a data scientist. You can email me. I'm also on Twitter, not that regularly active, but I'm trying to. And I'm a co-organizer of this event, League of Geeks. I really like data scientists, or I really like data science. That's why I decided to name my Spotify playlist like data science terms, so unbiased, maximum likelihood, non-parametric, identically and independent. And of course, I also created a playlist for today. It's called Deep Learning, so if you want to get into deep focus and need music for it, you can check it out. We have so far 0 followers, so because it's brand new, you can try out and have some fun. So, but now to the real topic, what we are going to do today. So I'm going to give you an introduction, what is TensorFlow basically, so that you will have a basic understanding of it. Then I will give you a basic introduction to machine and deep learning, because I think if you don't know the basics, it doesn't make any sense to start training a model or deal with TensorFlow. Then actually we are going to make our hands dirty with a hands-on session in computer vision in TensorFlow. Then there comes a surprise session, so stay tuned. And then what else to know about TensorFlow comes at the end. So everything that I have missed until then, I will tell you at the end very briefly. And then if you have questions, we can do it at the end. So what is TensorFlow? TensorFlow is an open source framework, especially for machine and especially for deep learning problems. It's actually a backend for huge data computations, especially numeric computations. The basic concepts are tensors and flow graphs, which I will tell you in a minute. And it's designed for CPU, GPU, and TPU, which is a tensor processing unit. And we have C+ in the backend, which is driving the performance. So if you're thinking about TensorFlow, you should know what are tensors. So tensors are, at the end, multi-dimensional arrays. So you will have, or you think about a single number or a vector, as well as a 2D tensor or even more like 3D tensors. Then you need to know what is a flow graph, because everything that is computed in TensorFlow is represented as a graph in the back end. So all the nodes will be the operations, and the edges, which you can see here, are the data that is flowing through the graph and is going to be processed. So as Sebastian mentioned already in the introduction, the first TensorFlow version 1 was released in 2015. And only a couple of weeks ago, they released TensorFlow version 2. So it's pretty interesting to know why they did it. What was the motivation for it? And they found out that a lot of people or developers and data scientists had problems in getting into TensorFlow. It was a lot of mental overhead, and it took a lot of time to get the basic concept of it and to get a model running. So TensorFlow 2 is basically everything about usability. They wanted to improve usability. What does that mean? Summarized, it means that there's a deep connection between now TensorFlow as backend and Keras as the most popular deep learning library at the moment on top of that. So you can think about it's a completely marriage. You cannot think about training machine learning models without using Keras. Then they cleaned up a lot of the API endpoints. That means in the version 1 they had a lot of APIs that you could use, but many of them were quite redundant or very complicated. So they decided to make it cleaner, increase the usability, and get rid of all those things that are not really necessary. Then what is really interesting is now you have the ability to use your functional programming style. So now, me as a data scientist, I like to use Python as programming for development, but in TensorFlow version 1, you always had to do these sessions and defining the graph and think about how it should run before I could actually execute it. And now we have the eager execution that comes with this comes by default, and now you can just program it in a way as you are used to it in other IDE. And if you have already something in TensorFlow 1, check out the website. I think I found it quite quickly. They are providing an upgrade script so that you are transferring and converting from TensorFlow 1 to 2. So under the hood, only very shortly, what can you see here is actually the background. Today I'm only gonna talk about Keras and TensorFlow because I am a data scientist. I don't really care while doing programming or while doing research and the prototyping. I don't care about the deep backend. I only care about that if I'm having huge data sets and if I want to put this in a productive environment. So today we are going to focus on Keras and TensorFlow. So what is the ecosystem for a data scientist? What do you have to know? So the development is mostly done in Python, so in Python programming language. Loading and pre-processing, you can use NumPy. I think many of you know it. It's the one of the basic libraries you use for metrics computations in Python, and the TensorFlow data module. Training or model training and building is used in Keras, and the deployment then can be done in Python too. We have some tools which are mentioned here. I will talk about this later. So what are typical use cases for which you can use TensorFlow? So we have text, like sentiment analysis. We have speech, as you know from speech to text or translation services. Images, audio, and also content creation. Today I only want to focus on image recognition or image classification. So let me give you a real example of what has happened already or what could someone achieved with TensorFlow. So I'm pretty sure every one of you knows Airbnb, the service provider for where you can book your apartments. So some years ago, Airbnb already decided to use TensorFlow because they had a huge problem. A lot of hosts are putting so many pictures of their homes onto the platform, but they are not correctly labeling it, or they completely forget it. So either it's imprecise or unprecise, or it's completely missing. So they decided to go through all of their images. I think they have more than 5 million homes, hundreds of million pictures, and they went through it and decided to use TensorFlow for prototyping and then later to scale up and to use it in production. So they are used TensorFlow, especially already they use pre-trained models, transferred it or developed it further for their explicit use case, and then use TensorFlow serving for bringing all these models, or to bring this model that they developed into a productive environment and to scale it up. So, introduction. I hope everything is now aware of what it basically is. So now we need to do some homework first. So machine and deep learning. Humans usually learn from experience, but machines learn from data. So machine learning is the way or the approach to extract knowledge from data and to know from it and to learn patterns. And then is the goal to build a model that is generalizable. So you take the training, you train on it, and then you try to build a model that is generalizable and applicable for the real world. There are 3 types of machine learning. It's supervised learning, it's unsupervised learning, and the reinforcement learning. For today, forget about reinforcement learning. You don't need it. So what is supervised learning and unsupervised learning? So supervised learning is you are supervising a model while training it. So you are the teacher and you're teaching a model with knowledge, so actually with data, which means that you have data that is labeled, so it has, for example, for a classification problem, it has the correct classes, and you are training a model by telling him these are the attributes of data and these are the correct classes. So this is supervised learning. Besides classification, you have regression problems, which is essentially the prediction of continuous data, like the number of products that are sold at a specific supermarket. You want to forecast this because then you have a better planning behavior. On the other hand side, there is unsupervised machine learning. And unsupervised machine learning is often used as a previous step before you can do the supervised learning. So unsupervised machine learning is that your algorithm is drawing some insights and learning patterns from the data without you telling it, which means you're using algorithm to find specific patterns inside the data, for example, finding subclasses of customers without even knowing what you're really looking for. We're not talking about unsupervised learning, we are using supervised learning today. So to make it a little bit more clear, think about a basic or a more easy understandable classification problem. So think about you want to classify shoes according to the type. This is a very easy representation of such kind of problem because for us as a human, it's pretty easy to differentiate between these two, right? Because it's clear, obviously, that this one is a sneaker and the other one is a high heel. But is it also possible to train a machine learning or a machine to recognize it? And for this, we have to see the different attributes that are important or that are describing this specific feature or this specific product. So here, for example, for the classification of shoes, you would need, for example, the features. Oh, it's not so good working here. You need, for example, the features, which are all the orange columns, which you can see here, like the percentage of material that is used. Does it have a heel? Maybe for which gender is it most likely designed? And then from this, you have a shoe type. And what you're doing in machine learning is you feed the training data set with the correct classes and the different features, so the information about the specific product. And then after that, you are trying to make predictions on data that the model has not seen yet. That's really important to get this idea of how machine learning works. And what are you doing then? Then it's all about model training and evaluation. So we are splitting our data set in a training and in a test set. And then we are training or feeding a model like machine learning, like a neural network with a training data set. So he is learning from the data how it is composed or what is inside in that. And then you're putting your test data set inside, and then you're making some predictions, and you're comparing the prediction results with the actual test data, which also has or already has the correct labels. And then you are computing a score out of that. So you do this normally not for one time, you do it for a couple of iterations to always improve your model, because you're feeding back what were your error rates, and then the model can learn what was right and what was wrong. And for the next iteration, it should be the aim to be even better and to minimize the error from the prediction and the actual classes. So, a very common problem in machine learning is over and underfitting. So, overfitting is when you're training your model so hard with the training data that it really overperforms for the training data, as you can see it here. So it takes every line, and this model is not generalizable, because when you now think about putting new data inside that, it could be something here, which will then will be not predicted quite well, because your model is so jumping around in this representation. So you will have a really bad performance on test data. On the other hand side, there is underfitting. So underfitting is if you're not really training well, so you have bad or only a small number of test and training, especially a small number of a training set, you're starting to train it, and your model could not really find the actual patterns in the data, and you're too fast in generalizing what is the underlying truth in here. So you will have a bad performance on training and on test. So maybe it was a little bit abstract, so I will give you another example for this. So just imagine a football player like this one here. Yeah, he's sitting over there, so hi. Just imagine a football player like here. What would be overfitting? So if he's only training to shoot goals with a right foot, and you're doing this for thousands of times only from the same distance, he is most likely to overfit, because in a match you have different situations, and you need to be able to take the ball with the left foot and with your whole body, and it's really important that or it's better than that you're doing less with the right foot, but also train the left foot a little bit more. So, and that's the same for underfitting. If you never go to training, you know the performance in the match won't be that fine. So I hope this made it clear. Yeah, deep learning. Deep learning is a subclass of machine learning. And actually, deep learning are neural networks. So let's talk about neural networks. What are they? So when you're seeing a graph or an abstraction of a neural network, you will have a number, or you will have an input layer that takes all the input data. Then you will have an output layer with, or maybe I start a little bit different. A neural network is basically, or is comparable to the idea of how our brains process the data. So first of all, you have an input layer, and at the end you will have an output layer. And what you see here, the points in the middle, that are the neurons, so the nodes that are processing the information, and if it has a specific condition, it is forwarded to the next neurons or to the next layer. So for a classification problems where you want to classify shoes and you have only two types of shoes or two classes, you will need two neurons in the output layer. So the connections between the different layers, these are the synapses, I would say, in English. So these are the connections to the different layers, and they are forwarding some information that are processed in the previous layer. So what we are going to do with machine learning, we are using this concept, and we are going to train the weights on them, because not every information that we are going to process is so necessary, but we need to know which information is necessary to make a specific action. So when you're going a bit further, it's doing like this. You have the input features here, and the model will estimate or train on the weights, and together with the input information and the weights, these are summed up at every neuron. And then we are going into an activation function which evaluates the information that it got from the neuron. So, and if these activation function reaches a specific condition which is mostly set beforewards, either this condition is met, then it will be pushed forward to the next neuron, or this condition is not met, and for now we could say we forget about this information, or it's going backwards into the previous layer. So So the activation functions will be quite important for our later use cases, because the activation function, as I said, are most important to decide whether a neuron takes the information and pushes the information forward to the next layer. So we have three different, or there are many different activation functions, but these are three activation functions that are worth mentioning. So there is the step function. It only takes, or it only has output of 0 and 1, and only if a specific condition is met. For example, the sum that is generated at a neuron is increasing 0, the step function will return as a 1 and is forwarding this information to the next layer. The sigmoid function, which you see in the middle, is more like an S-curve, so it also takes values in between 0 and 1 and is taking this information and push this forward. And one of the most interesting activation functions and one of the most used activation functions is the ReLU. So the rectangle, I don't know exactly, but I will look that up later. So the ReLU in the short form is the most important or most common used activation function. And it's interesting because if the sum is increasing 0, the neuron is fired, and then it forwards it forwards the sum of this neuron and pushes this forward in the next layer. Only two information what you need to know further. So as I said, we are trying to minimize the error in the model. So what you are defining when you are training a model is you are defining a loss function as well as an optimizer going on that, because in each iteration training we want to minimize the loss or the error on that. For this approach we are normally using a gradient descent approach. I don't want to go too much into details here. The only thing that you should know and take from this talk today is that normally it's the backpropagation in neural networks, and I think if we go too much into the mathematics behind, many of the people are leaving. So better continue. Do it in TensorFlow. So important to know if we are thinking about computer vision and image analysis is to know how does a computer sees. So a computer only can process numbers. So you need to know that every picture is a number or a representation of an array which consists of numbers. So the basic representation of an image is black and white. So maybe you can see what's on that. Maybe you in the front. I think it's obvious because it's me standing on the Brooklyn Bridge in New York. Right? No? Okay. So it has a representation of black and whites and only takes, so each pixel is either has the representation 1 or the representation 0 for black. Let's think about a grayscale image. So it's actually the same image, but now you can see it's me actually not lying, standing on the Brooklyn Bridge in New York. So a grayscale picture is a picture or is a representation of an array with numbers that has a value range between 0 and 255. So 255 is white as well as 0 is black. So and everything in between is a kind of gray, so a little bit lighter, a little bit darker. Yeah, two-dimensional array, yeah. And then we are having the RGB representation of an image, which is pretty important to understand because we are actually having the same representation or the same range of numbers inside the arrays, but we have 3 dimensions. We have the dimension red, green, and blue. And this will be very important when we see it later in the code, how this turns out to be implemented within the arrays. So this is actually an example for a black and white picture. So you see that's a NumPy array only consisting of 1s and 0s. This is the grayscale picture. and this is the colorful picture. So now I have a question for you. What are the most popular data sets used in data science for cross-sectional data? Does someone know? No. Sorry, maybe yes, but not in my case. So where are the Kaggle computers? Sorry?
Handwriting.
Cross-sectional data. So tabular.
I really don't know what cross-sectional
Tabular data. So let's say tabular data.
Okay, yeah, thank you.
Any idea? Come on, one logic guys. Make a guess.
It's the Titanic.
Yes, thank you. What else? Maybe another. Okay. It's Iris, maybe you know it. It's Titanic. So, and there is one. So when you're thinking about getting into computing or making image analysis, of course it's MNIST and then thank you, it's the handwritten numbers. So we are going now to give you, or now I give you a short demonstration on how to build a neural network on the MNIST dataset. And I chose this dataset especially because it's already integrated in Keras and every one of you can use it. And that was really important for me, if I show you something, that you're always able to reproduce it later on. Oh no. So what's about the size? Is it okay? Okay. So I created a Jupyter notebook, and the plan is that we are training a neural network now, and I explain you what I did and how you can do it to understand, or how you can do it your own. So first of all, we need to load all the modules. It takes some seconds because I'm only using TensorFlow here on a CPU. I do not have a GPU on my Mac, but for the small examples and for getting started, it's totally fine. And now we are already using the Keras API, and we are loading the MNIST dataset in that. Then we are splitting our data in training and in test, because we want to train a model which is, of course, here supervised learning. So what is the shape of the data? The data comes with 60,000 training images, so these containing the labels, and 10,000 images on which we are going to train on later. Yes, maybe then you believe me. This is a short representation of the data. And now let's build a neural network. And what is really fantastic and comes with TensorFlow is what I said in the introduction. It's very close connected to the Keras API. So if you want to getting into training a neural network, you should use the sequential API. And it's interesting because line per line you can add new layers to the neural network, and that's it. So for example, if you're looking at this code, first of all you have to define a layer that is flattening the data, because we are having images 28 by 28 pixels in the size, and first of all we have to flatten it. So this dense neural network, he needs a flat representation of the data, so everything has to be in one vector. So that's always the first layer, or it's basically the input layer, and you are defining the size of input. Then I decided to define another, or to define the first dense layer. So the dense layer is what we are thinking about, the normal neural network. So every neuron is connected, or every neuron of one layer is connected to the next neuron, or to every neuron in the next layer. So when we are defining a dense layer. Here, first of all, you have two arguments which you have to pass. So first of all, how many neurons do you want to have? I'm not yet completely sure what kind of number is correct here, but I think if you're really tuning your model later, you should always do some hyperparameter tuning, which is for a beginner not necessary, I would say, but I read that about 100 is not that bad. And as we have seen in the machine learning basics, we are defining an activation function, which is really important for the specific task that it should do. So here we are using the ReLU activation function. And at the end, we are having the output layer, so again a dense layer. And as we have 10 digits and we want to predict we want to predict whether the number belongs to which of these 10 classes, we also need 10 output neurons in the output layer. And then the activation function is a softmax. I know I have not talked about this, but it's very similar to a sigmoid function. So it gives you the probability of how high is the probability that the prediction falls into which class. And later on, we can take this class with the highest probability and then have an output and can compare whether it works out or not. So that's all. That's for defining how the model looks like. And when you are checking the summary, you will see what we are training now. So here you will always have the shape of the neural network. So we are having 0 parameters in the flattening, but 20, yeah. Then we are having the dense layer, the first hidden layer that has 128 neurons and more than 100,000 weights to train on. Then we are having the second dense layer, which is the output layer. So we are having 10 neurons here and 1,290 weights to train on. So in summary, more than 100,000 parameters to train on. When we are compiling a model, we have to define the type of optimizer. I told you we need a loss function, so the one that is minimizing the error, and an optimizer. So here I decided to go very basically, so I know that, or I have read that Adam is a quite good optimizer, and the loss function, as we are going to predict categorical values, it's a sparse categorical cross entropy, but I don't want to go too much into details here. The most important one is that we are defining the metrics and we want to see or we want to evaluate on the accuracy. The next one is the fit function, and what you're defining here is the number of iterations, so epochs. So how often is the training iterating? How often does it repeat? So here I decided to go with 10 because I want to execute it now and it shouldn't take too long, and now it's working. And what you can see now is it's very important because the first iteration is with randomly set weights in the neural network. And after that, we have the first prediction, and then we can compare how well it was and can return the wrong classified ones. And what you see here, it's really important that the loss function on the training is always decreasing. So this is a good sign. Let's see on the validation loss. Yeah, it's also decreasing. Now here it's increasing. Let's see later in the graph what has happened. So now we have already, with this basic neural network, an accuracy of 97%. Not that bad, I would say. I don't know what you can get if you're really, really good, maybe 99% or something, but well, I think for today it doesn't matter. You want to learn, right? And I think this is a really important representation. So when you're going to train a model, you should always take a look on the training and the test accuracy, because this gives you a hint whether your model is going to overfit or not. So it should be really important. So when your test data or the curve of the testing is going to decrease here, so the accuracy is going to be worse, it's a good hint of that you are going to overfit, because the model learns too much on the training data and cannot perform well on the test data. So let's do some predictions. So just for 5 examples. So this is now a prediction. You have the prediction results compared to the actual results, and I think they are all pretty amazing. So the probability is also really high. So I would say it's fine for this. But we have really good data here, so don't forget about this. Data is fantastic. It's a training data set, and we're going to getting started here. So, well, now we can decide whether we are continuing with a convolutional neural network, but I would say according to the time, I would skip that, and if someone is interested in it later on, I can provide with slides and code, because I have the same for convolutional neural network, but we leave that out for today. Good. Then let's continue. I have to go back here. So let's continue with the surprise session. So who has attended last League of Geeks event? Okay. So this is Manu, and Manu is the speaker of last League of Geeks events. So hi, Manu. And Manu is really crazy about tracking himself. He thought about that last time. So he is really into this, and he also, well, this is also Manu. This is also Manu, which I find really amazing. And yeah, we have so many pictures because Manu is so crazy about tracking himself that for 8 years already, he is taking a picture of himself each and every day. So, and I thought last time, sounds like an interesting data set to analyze, to make some analysis on that. So, and I asked him whether he would be polite enough to provide me with the data, and yeah, only 2 hours later, I had the data set in my mailbox, which was pretty amazing, and then I was thinking about what can I do? And while scrolling through the data, I found this. And I asked myself, ooh, is that too sexy? But why don't ask a neural network about this? So, going back to this. Yeah, Manu.sexy. So I have already pre-trained it, and now will only show you the results of the training and what we have done. So now it's even harder to make the analysis, because now we have real data, we have to load it, we have to pre-process it. Due to time issues, I don't want to go too much into details. This is Manu, by the way. And I think you provided me with more than 3,000 pictures. But I decided to make a training on a short or a small data set. I think I took about 1,000 images, and I had to label it beforehand, which was quite a little bit nasty because I had to see all these half-naked Manus, but okay. And because you're changing your phone over time. So we had the pictures in different sizes, and I had to resize this to make it comparable. So that's the resizing point. So now Manu in another color shape. And then I go. Yeah, this is the most important one because, of course, I had labeled it, I had different folders, I loaded it into this Python notebook, and then I had to shuffle this one because I need a training data set that is representative for the real world, I always say. So I shuffled it, I pre-processed it, so bring it in the right format. So we have 700 for the training set and more than 300 for the test set. And this is how the array actually looks like, the feature array. Because we have RGB numbers now. For the MNIST dataset we have had grayscale, so it was much more easier with the dimensions. So, and then I decided to train a model really similar to that one that we have seen beforehand in the before section. So it's a sequential model, it's flattened in the first input layer. Then we have two hidden layers, one with 120, one with 64 neurons, and then the output layer, because I only wanted to predict or ask myself, is this neural network able to differentiate between Manu having a t-shirt and Manu is half naked. So we have two outputs, naked or not. And what is new to here is, besides defining the same optimizers as in the previous example, I also defined a learning rate, so in which way the algorithm is learning or is or how fast it's improving the learning. So we are now training 37 million of weights, so just a lot, but for only 5 epochs it takes not that much time, but I don't want to blow up this today. So we are fitting the model, and yeah, we have an accuracy with this model of 91%. I think this representation looks also not that bad. So training and test is quite okay. Maybe here we should be a bit suspicious. So maybe we are a bit overfitting, but we are only having Manus here. So I don't mind if we are a little bit too specific in this model. As long as the loss is decreasing over the iterations, I think it's fine. And the thing that I want to give you is this. So I analyzed how good the neural network could classify the images, and it could correctly classify the image as being too sexy in 94 times and as normal ones in 249 times, and only in 10 times it was classified as too sexy, but it was normal. And yeah, let's take a look on the examples here. So it looks quite good, I would say. Even this one, it's amazing that it was correctly classified. And we have different light situations, so I think it was an incredible result for just try out, and not so bad. And here, this one. I think it's obvious why the model couldn't differentiate, because you wore a sweater that looks pretty much similar, or a lot similar to when he's half naked. So, well, it's okay, I would say. And I think here is also fine, so it's pretty hard, right? So the data is not so clean. So it's clean, it's only Manu on that, but it's not so easy because your representation on the image is not always 100% the same. So, yeah, because it was so nice. So, okay, final chapter. So what else to know about TensorFlow? What you should take away from this talk? So what I have not talked about is the TensorBoard. It comes with the framework TensorFlow, and it gives you opportunity to visualize your training performance on the way. So now I use the Python and the matplotlib library to show the visualizations, but it actually comes with TensorFlow. There's the TensorFlow Model Hub, which provides you with already pre-trained models. So if you have a complex problem, don't try to train a model from scratch. Try and try out or check out the TensorFlow Hub and think about using a model and then make some transfer learning and modify it in a way that you can use it for your use case. TensorFlow is also applicable for many different devices. So today we only talked about this part, but it comes with quite more. So there are already models available on your mobile phone and working. And it's also possible for desktop applications or for web applications. And if you're trying to scale that up, because now we had only a small size of data that we had been looked on, if you're really interested in doing a real project and bring that into production, you should check out the TensorFlow extension version, which comes up with model serving and deploying. So for production, I think what is inside TensorFlow is that you will have this serving and saving opportunity, and if you bring that in production, you are generating an endpoint on which you will then pass in your data, and then you will get a prediction in return. If you are interested now in getting to know new or getting to know more about neural networks, I found this very interesting playground. It's also provided by TensorFlow, and then you can define different types of neural networks. You will have different kind of data sets, and then you can better find out what are learning rates, what are optimizers, and what you should use best. If you want to learn more, there is for German-speaking people this Udemy course. I really liked it. It's quite intense, but the guy is really good. There are, of course, many more courses outside in the internet, and I think there are a lot of options to get into the topic. And of course, what I can always recommend, if you want to start with data science, check out Kaggle. It's the platform for data science. There are so many competitions and data sets on which you can train on. You can take part in competitions. You can also earn some money if you're really good in that. So check out this one. And finally, before we end, maybe you will think about now, this talk was called TensorFlow, but we does not have seen so many TensorFlow, right? Yeah, that's true, because for this talk, I said I wanted to do a getting started session to give you a good overview and to give you a use case for me as a data scientist and what is important for me when I do my research and when I want to do a prototype. And for prototyping, or the really good in TensorFlow too, is now that I do not see so much from the back end. I use the Keras library, and in the back end, TensorFlow is processing the information. But I don't really have so much to do with TensorFlow when I'm in the research and in the prototyping part. So, thank you.